As I have done in the previous example, I'm going to first just talk about the three statements that are important to us for a proof by induction, and then in the next video I'll prove this statement by induction. Our domain here is the natural numbers. Remember, the natural numbers are different than the positive integers because they start at 0. Okay. Now, this is our P of n. And we're interested in P of 0 because we're using the natural numbers, not the integers in this case. P of k and P of k plus 1. Now remember, P of 0, we prove P of 0, that's the base case. Assuming P of k, that's the inductive assumption. And P of k plus 1 is the thing you want to show. If you assume P of k, show P of k plus 1, then that's the inductive step. Okay, P of 0, this is 2 to the 0 is equal to 2 to the 0 plus 1 minus 1. That's P of 0. P of k is plugging in a k for n. That's 1 plus 2 squared plus 2 to the k is equal to 2 to the k plus 1 minus 1. And P of k plus 1 is 1 plus 2 squared plus 2 to the k plus 1 is equal to 2 to the k plus 1 minus 1. Now what's this thing that comes before 2 to the k plus 1? That's the, so remember this is the k plus first term. That's the rule being that thing, 2 to the n. That's our rule for the left-hand side. So we plug k plus 1 into our rule for the left-hand side, and that gives us 2 to the k plus 1. Now we want the kth term, so we plug in k to our rule for the left-hand side, and that gives us 2 to the k. All right, so these are the three statements that we're most interested in for a proof by induction. And I'll prove this result in the next video.